Okay, so this is going to be a two-part series on how to conduct an analysis of variance F-test. It's two parts because it gets a little bit more complex, but also because there are a couple new ideas in here. And with three groups, you have more groups than we were dealing with earlier, so it just takes a little longer. So what I'm going to do is do this video where I'm going to introduce a study so we don't have to do stair climbing anymore and heart rates. I'm going to show you how I collected data for this, and then we're going to prepare data for step 3. And in the second video in this series, we'll actually do the 4 steps of the hypothesis testing part of ANOVA. So we're just getting ready for step 3. And I want to talk to you again about the concepts of between groups versus within groups variance. Those are the two types of variance that we analyze. Now, as we're going through these two videos, you'll probably have to hit pause a few times. This might be a good time to do it. Before we do this, I recommend getting a sheet of paper like this and then put step 3 at the top. We're going to put 2 data tables on here. And it'd be useful, I think, if you have that ready. So when you're ready, come back. All right, so here's the test I wanted to do. There's this test developed by a guy named John Shroop back in the 30s, and it's about attentional control, which is something I've been interested in as a cognitive psychologist. And almost everyone has seen some version of this at some point. In this, he's looking at 2 parts of attention. Attention involves a goal, which is, in this case, naming the color of the ink or the font. He did it in ink. I'm doing it with a font. And to do that, sometimes you have to inhibit the written words. So this first line here, you've got blue written in blue, orange written in orange, green written in green, and so forth. But on the second line, notice here, this is blue, green, red, purple, orange. You have to inhibit the written word to name the color of the ink or the font. It sounds like a party trick. It's actually kind of important. So like what we've realized today is that attention is actually 2 separate things. This is part of the dorsolateral prefrontal cortex. That just means the back part of the prefrontal cortex. So that would be up here. And that has kind of goal-oriented, so it has you looking for certain things. And then this is the ACC, the anterior cingulate, which is a little further behind it. This is the left side of someone's brain. Here's the right side, so that one's looking that way. But both of these are bilateral. All right, so we know that this is a way of measuring people's attention. It's also a way of sort of diagnosing the extent to which someone's brain disorder, brain damage, injury, stroke, that kind of thing might be affecting them. We're going to do this on people who we don't suspect to have any problems. So I developed 3 conditions, blocks, words, and Shroop, and I got 12 people to do this. So this is Maddie Hoffitz. She's at home, and I'm going to tell her to go. When I say go, I'm going to hit a button, and that'll pop up on her screen. As soon as that pops up on her screen, she's going to start naming the colors in this pattern as if she were reading. And I will start a timer as soon as it pops up on her screen. There's just a little delay. You ready? Get set.
Ready.
Go.
Red, blue, green, yellow, green, red, blue, yellow, blue, red, yellow, green, blue, red, red, green, yellow, blue.
All right. How long did that take you?
8 seconds.
8.9. All right, so that's a block condition. In that case, I just wanted to see sort of a baseline, how long it took people to name the colors. Now, in that earlier slide I showed you, there was a situation in which the colors matched the ink or the font, and I'm doing that as well. In this condition, I'm calling it just words, and that means that red is written in red, blue is written in blue, and I've got Vanessa here, a great statistician in her own right, is going to participate in this one. It's going to have the words matching the color. Okay? On your mark, get set, go.
Red, blue, green, yellow, green, red, blue, red, yellow, green, blue, red, green, yellow, blue.
Oh, wow. That was good. I have 7.3.
Have I beat my time yet?
All right. So the word Vanessa's roommate Tracy is kind of competitive here. So I'm kind of glad she got the Stroop condition. Stroop had his test with the ink not written in a different color than the word it spelled. Well, that's hard to say, but I'll explain that to her as well so you can hear it again. But anyway, let's see how she does. All right. Tracy, you ready?
Yeah.
Okay. This is the Stroop one, so it's going to be mismatched. Ignore the letters.
And the color.
Name the color of the font.
Okay.
Ignore the letters. Okay? On your mark, get set, go.
Yellow, green, blue, red, yellow, green, red, blue, green, yellow, green, blue, red, yellow, green, red, blue, red.
Not as good as last time. It's 14.1.
But I feel like someone got in 18 seconds. I did not get 18 seconds.
All right. All right. So they got a little competitive. But let me show you what we have here. So earlier I said it'd be good to prepare a table to get ready for step 3 in the next video. So in this table, what I'm doing is I'm setting up 3 columns for my block condition, which Maddie did in 8.9 seconds. The word condition, Vanessa did that in 7.3. And the Stroop, or the mismatch condition, which Tracy did in 14.1. I got values from other people, so this is going to be independent samples. So I'm not comparing these scores directly to each other in my analysis. But before I show you the other scores, what I want to do is bring up this idea of between group variation. So in analysis of variance, we look at 2 types of variance. The main type, the type the researcher is interested in, is the between group variation. And when we analyze this, what we're asking is there something about being in a group that causes or determines the amount of time it takes? So look at this. Is it 8.9 is definitely not the same as 7.3. Why is that? Is that because there's something fundamentally different going from block to word, or is it error? In other words, is Maddie just a little bit slower than Vanessa? Was there maybe a little bit more lag in the network when I was timing Maddie versus Vanessa? We don't really know because I've only got a sample of 1 in each. So before I can say block is 8.9 seconds in the population and word is 7.3, I need to have a bigger sample. So I'm not quite ready to say that words are inherently faster than blocks. Likewise, Stroop took a lot longer. I could actually see at the beginning of the second row when Tracy's ACC kicked in and started messing her up, started detecting problems. I personally think that the Stroop condition is what causes Tracy to take almost twice as long as Vanessa. But I don't know that. Tracy just might be a really slow color namer. All right, so the next screen, what I'm going to do, and you can hit pause here before we continue, is I added 9 more data points. So I have an N of 12 overall, but an N of 4 in each condition. So why don't you fill out your table, and then, or hit pause, fill out your table, and come right back. Okay, now earlier I said that I'm really curious about between groups variability. I want to know if the block condition is fundamentally different from the word condition, or is it really just about sampling error? Well, here's how I look at sampling error. This is within groups variation. So notice that not only did Maddie do differently than Vanessa? Maddie also did differently than, who is this? This is Jonah. This is my son, and a couple other students here. There's within groups variation. Some people are just faster than others. Again, there might be like a network lag. I might have been a little bit slow to respond with the timer, things like that. And then that's true over here as well. Not everyone did it at the same pace. You see there's a fair amount of variability there, and again there. So I'm wondering, are these scores different on the whole from these scores? And are those different on the whole from those scores? And if so, is that because the condition causes the change, or because people are just different from each other? That's fundamentally what ANOVA is going to do. All right, so in order to finish preparing for step 3 of our ANOVA, here's a second table I want you to take care of. Notice that this table has the exact same data, but here what we're going to do is I'm asking you to calculate the sum of x squared, and n for each column, and then the sums of squares for each column. So you'll wind up with the sums of squares for each. After that, I want you to create this. This is the sums of squares total. And what that means is that this will get you the sums of squares for all 12 observations. The easiest kind of shortcut way to do that is to add up your sum of x's, add up the sum of squared x's, add up your n, so that'll be 12. You don't add up the sums of squares though, you use those 3 values to calculate. So I'm going to ask that you fill this in and have that ready as a guide for when we start the next video and we actually conduct ANOVA. Excuse me. So here's what we did in this video. I wanted you to get a sense for what the study looked like. Maybe you even try to participate in a little bit by naming those colors on your own. It's worth trying to do. We got our data. We set up our tables for step 3. So what you need to do before the next one is calculate those values to fill in the 2 tables. The first one was mean and standard deviation. The second one was the sums of squares value. And then before we start, there is a copy of an F table. It's in our old Google folder from when we were still meeting in person, but I'm also going to put a link to it on the page. And what the F table does is it provides critical values just like the T table did when we were doing t-tests. So we'll need that for step 2 of the actual ANOVA. So get that ready, and whenever you're ready for some fun, start the second video.